Okay, hey class, Mr. Bean here. I'm with my A1 class today, and we're making a video to help us with the assignment is problem set 1B, questions 3.25 through questions 3.34, dealing with what we call kinematic equations for horizontal motion. So when you do the problems today, you want to work them with your group. I think it's only 10 questions, and you want to insert your answers onto a Google form so you'll get instant feedback. All right, so when we start here, this is a video you can kind of watch later to kind of help you out a little bit. So here we have these 5 equations here, and we want to go through them and kind of discuss what they are or what they talk or what they mean. Okay, and we'll go ahead and use a different color pencil here. We'll use red. Okay, use red here. All right. Okay, so this one here is talking about distance. Okay. All right, sorry about that. Okay, so this here is talking about distance. Okay, so this is talking about distance traveled. Okay, distance, and we'll go ahead and write that down. Distance here, and so this is distance, and this here is speed. Okay, so this is talking about speed, right? Okay, so distance is basically. Oh, hold on. This should be not x. This should be. Uh, Oh yeah, distance. This is speed, and this here is elapsed time. Okay, elapsed, uh, uh, elapsed, uh, elapsed time. All right. Okay. All right. So we've been kind of working on this on that couple. I think some of the videos, uh, uh, first couple of videos talked about these two things here. Okay. So this is like equation number one. Number two is broken into two parts. This here is talking about average velocity. Okay, average velocity. Okay, average velocity. Okay, average velocity. Okay, so average velocity is basically we have some new variables. Okay, this is v here, it's a vector. It's the final position minus the initial position divided by the elapsed time. That'll give us average velocity. Average velocity can also be found by taking the final velocity plus the initial velocity and dividing by 2. Okay, so these are two ways to find average velocity. Now, up to this point, you should at least done 4 simulations already that deal with average velocity. Okay, now some people have not done them yet, and so they might be at a disadvantage. Okay, all right. So now I'm going to ask a question here. Do we remember what instantaneous velocity is? Okay, so I'm not asking the class here because maybe a few people know. So here we have delta x over t, right? And let's say we had it kind of look like this, a graph, right? Now, if I want, let's say I wanted to find the velocity, the instantaneous velocity at this point here. Okay, so I'm going to ask the A1 class. Does anyone know how to find the velocity, instantaneous velocity? Who said slope? Yes, found the slope. Yes, all right. Uh, uh, yes, you've restored faith in my class. Yes, good job. Right, my faith is restored. Yes, I would find the tangent line like this here, and I would find the slope of this tangent line, and that would get me the instantaneous velocity. Now, consequently, when we have our first exam, this will be a question that I would ask you. So when I come up here and ask you a question, it should only take you 30 seconds for us to interact. So I would ask you, tell me how you would find the instantaneous velocity, and you would say the slope. That would be 100%. Okay, you have convinced me that would be the minimum requirements in my class to get a D in my class. D is in passing, 60%. Okay, all right. So this is yeah. So excellent, good job. Now over here, equation number 3 is acceleration. Now we just kind of worked on acceleration in a problem set, also in the video. And so here acceleration basically is uh, final velocity minus initial velocity divided by the time interval. And I can also rearrange it by doing heroic algebra. And I can solve this for v and get velocity equals VO plus AT. Now, consequently, does anyone know what equation this looks like? Think of algebra 1. What's the most famous equation that we use in algebra 1? Is it? Yes. So this would be like y, right? This would be like the y-intercept this would be like m, and that would be like x. Yeah, exactly right. Yes, exactly the same. All right. However, now another question I would ask you in a demonstration would be kind of like this here. I would say, suppose this is velocity and this here is time. And let's say I had a line that looked like this. Okay. I would ask you, what does the slope tell me here? Anybody? Okay. We just did this last class. Yes, we said acceleration. All right. Hey, good job, man. Yes, the slope is the acceleration. Supposing we did this 5 times, right? Remember the slope tool? Okay. All right. Yeah, it is the acceleration. So, questions I would ask you would be, for example, probably just these two questions here. You come up here, I'd have a deck of cards like this. I'd say, pick a card. You pick one card, and one card might be something like that. I'd ask you, how do you find the slope? Or what does the slope tell you? So those are the kind of questions I'm going to ask you that are like learning targets. That's the minimum requirement for you to demonstrate understanding, to demonstrate understanding that I would be convinced that you could pass my class. Okay, that would be the minimum. Okay, all right. So this is acceleration. Okay, now these are two new ones. Okay, now we won't try to show where they come from, or this one here is equation showing displacement. Okay, this is delta x. This is initial velocity. This is time. Okay, and this here is, of course, 1/2 is 1/2. Here's acceleration, and this is time again. So this is an equation that sometimes we would use to find displacement, initial velocity, acceleration, or time. Okay, so we have to practice that today in class. Okay, and this other equation over here is velocity squared equals initial velocity squared plus 2 times acceleration times the displacement. Now, in this equation here, I would use this where time is not given. Suppose we don't know what time is. Okay. All right, so that's pretty much it for today. What you're going to have to do in today's problem set is that we're going to be using 2, 3, 4, and 5, and some combination for you to solve problems. Okay, so I am here to help you with the question. Now, I won't do well. I might do some of them for you or help you out with them, but try to work it in your group. If you're not sure, make sure you ask me for help. Okay. All right. So I'll go ahead and upload this to YouTube, and that'll be it. So make sure we do, I want to call this here, what, problem set 1B. So we'll call it problem set 1B. Okay. And we're going to do questions, looks like questions 3.25 out of the study guide through question, was it 3.34? 3.34. All right, this looks at 10 questions, and go ahead and make sure you answer them on Google Forms. All right, that's it.